Hi guys, can you hear me? Am I coming out with the microphone? Yes, I am. Hi, I'm Jabe. I'm getting my PhD at Carnegie Mellon right now in what's called transition design. I study change over very long periods of time in large organizations. So what's very long? Transition design's objective is to understand how we're going to move to a more sustainable society. The people who have come up with that idea believe that that is a project on the scale of the Enlightenment. So the time frame we're talking about is 400 years. And the social system we're talking about changing is, global. And so it's a pretty abstract thing when you get up to those sizes. And I try to learn as much as I can by working with large organizations who are undergoing change and helping them to think through transition design. I do that in my consultancy, which is called PraxisFlow, which I run with Kevin Baer, who is one of the co-authors of the Phoenix Project. I want to first explain what frames are to you guys really quickly. My thesis advisor would tell you that I should be able to explain my thesis in 10 minutes. I have not achieved that yet. But I'll go as fast as I can and try to keep it as coherent as I can when I'm doing it. The first thing about frames is to understand something. I also say that this is this version of frames is maybe not one you'd hear normally. It's my version of understanding frames. So I think it's coherent, but it is not something you're going to look up and read somewhere else. The first thing to understand is this idea of what we call bounded rationality versus global rationality, and it's by a guy named Herbert Simon. You're going to hear a lot of quotes from Herbert in this. Global rationality is the idea that you can have a rational discussion kind of atemporally, in any place, at any time, and come up with the same decision. Whereas bounded rationality is this idea that actually you are embedded in some specific time context, some specific temporal context, some specific subset of the universe, and you have to make decisions about things without being able to use global rationality. And that is because your decision making is bounded by how much, if you want to use a purely computational theory, how much information you can load into your head before you have to make the decision. So the more information in theory, the better. And then that will optimize or maximize your decision making. That's the theory of kind of global. And bounded means you can't load all the information into your head. And therefore, you have to select some set of information to load into your head in order to make your decisions. The result of this is what Herbert Simon calls the difference between satisfying a question and satisficing a question. A satisfied answer would be a maximally efficient answer. A satisficing one would be the best you can do within the bounds that you have on your ability to think about something in time, in place. So the result of this, Herbert says, because all humans are bounded in this way, is that he says that the most scarce resource in any organization is not information, it's attention. So it's not, you don't need more information in most organizations, you need to be paying attention to the right things. And the difference between this is where frames start to kind of gel or start to become something you need to be concerned about. Because frames, in essence, tell you what information to pay attention to. This is information, and then tell you what not to pay attention to, which in theory is called X-formation. It is equally informational, but it is the stuff you've decided not to look at, X-formation. So all frames, just like you have on a camera, select a part of the world and leave part of the world out, otherwise it wouldn't be a photograph. So that is kind of the beginning of frames. So Goffman explains it this way. He says, when you find yourself in a situation, the first question that you have to ask is, what's going on? Where am I? What is happening right now? And he says this either happens explicitly when you're actually confused and you lean over to your friend and say, I don't understand what's happening, or tacitly. In other words, every day when you're making decisions, the first thing you have to do is situate yourself in a context using something like a frame. And it is this frame that then enables you to actually make decisions about what to actually do about the situation that you find yourself in. So a frame is a way of selecting what to pay attention to in a particular situation so that you can decide what to do next. Here's some funny words to kind of get us a little bit situated about how frames work. The first one is ontology. So an ontology is simply a list of the things that exist. Yes? And so when we talk about frames, we're making ontological design decisions. We're making decisions about what we're going to pretend is real and what we're going to say isn't real, right? So stuff that we're not going to pay attention to. So an ontological design is a process by which we decide these are the things that are valid to talk about, and those things over there are not valid to talk about. I keep on saying things because it's literally things that we're pointing at right now. Then, once we understand kind of what things are valid to talk about or not talk about, we can talk about epistemology. And epistemology is how can we come to know the things that we've identified? In other words, how can we find out more about these things? What skills can we apply to these things? What is the epistemology that allows us to structure our decision making about the ontology that we've defined by having a frame? These two things then combine together to create something. I didn't put the name of the word up there, but it creates what's called an arothetic set. Now, you have to be careful saying arothetic because it can come out the wrong way. But arothetic is the logic of asking questions. So this is important to think about with frames. A lot of people, they stop at epistemology and ontology, but actually the point, if you go back to the Goffman thing of a frame, is to enable you to ask, what am I going to do? And the way that an arothetic works is that it says, there's a certain set of presuppositions, that's your ontology. There's an area of inquiry, that is what's in your ontology. And then there are questions that are legal to ask or not ask based on those presuppositions and the area of inquiry. Give a really quick example. At one point, you could have been in a major university and you could have had a large amount of funding to study ether. And ether was the matter in the universe that was between all the identifiable matter, yes? It was a fluid or a substance. People didn't know what it was. It was a valid question to be asking. You could ask it in an academic way, in a very serious way. You could be funded to study it. Einstein shows up, and the next day, everybody who was studying ether, poof, they didn't have anything to study anymore because ether was no longer a valid thing to talk about. It disappeared out of the ontological set of things that could explain what we see when we look at the cosmos. So one of the ways to think of arothetic and frames is that there are, when we discover certain things about the world, certain presuppositions about how the world works eliminate the questions we're allowed to ask about the world anymore. We just can't ask them anymore because they're not valid questions anymore. This leads us into this idea that we have things, ways to know things, questions that are valid to ask about the things with the ways that we can come to know them. And then we get this idea of coherence, narrative storytelling. And the idea of this is roughly that the first one's pretty obvious to most people. It's retrospective coherence. It's the idea that you have a problem in your life, the servers crash, and after you put the servers back together again and try to explain how they crashed, you get what's called retrospective coherence. You can explain clearly how it happened. The problem is that if you could have explained clearly how it happened before it happened, then it wouldn't have happened at all, right? Because you would have stopped it. So it's only in retrospect that the story, narrative, the way that the things come together makes sense. There's a second piece which is important with frames, which is what's called what I call prospective coherence. And what it says is there's certain things that if I change the world, I'm going to have to be able to explain in the future. And so I can think forward about what I want to do and then try to figure out what questions will be caused by using this particular frame, for instance. So I can project and try to understand what prospectively I will have to be able to narrate. one more weird version of kind of frames to get people situated in this. This is called the cones of the future, or future cones. And what you can see, let me see if I can get my little pointer to work here. In the middle here, you have what are called probable futures, yeah? And probable futures, you just have to think of it as, if I don't act at all, this is what probably will happen. This is what I believe is likely to be the outcome of not acting. And then from there, you can say that there's also plausible futures. I could imagine that if like this happened or that wiggled the wrong way, that it wouldn't end up in the probable future, but it would end up in some space of plausible. The important part being that I can conceive of it existing in that way. Yeah? I can actually, it's in my ontology, and I have an epistemological way of describing and talking about it. Yeah? In the aerothetic version, plausible futures are futures that I can actually ask questions about. Yeah? There's a last one, which is the possible futures. And that kind of is, it's outside the cone. And the idea of the difference between plausible and possible is that there are futures that could exist that I can't ask questions about, therefore I can't conceive of. Doesn't mean that they're less possible, it just means that they're not plausible. So your frame is, in essence, a way of differentiating what's plausible from what's possible. There's a tipping point edge there. The stuff that's implausible is the stuff that is inside of plausible as opposed to implausible. Stuff that inside of plausibility is stuff that you can have a conversation about. The stuff that's just possible, you can't even talk about it yet. And then the idea of kind of prospective coherence is saying there are preferable futures. And preferable futures means that inside of the cone of what is plausible, I can select where I want to go that is away from what is probable. I can change the trajectory of the future, yes? So these different ideas allow us to talk about the idea of a frame being temporally extended. It is in time, it flows forward, it allows us to ask questions, but it also critically allows us to make predictions about what's going to happen. For Weck and some other people who are interested in mental models, this is a critical difference between high-performance teams and low-performance teams. Low-performance teams use frames, mental models, to stop thinking about what's happening because the model tells them what to do. High-performance teams use models to lower their cognitive load so that they can pay attention to when the model and their predictions don't match, so that they can act. Yeah? So it's an important thing to understand the difference there. There's another weird kind of interrelationship here, which is the relationship between plausible and probable, which I'll get into a little bit more. But it's important to note that what is plausible means you actually look at it often, and therefore it increases in your mind the likelihood of its probability. It makes you think it's more probable because you see it more often, yes, because you're focused on it. So there's a feedback loop here where your frame self-enforces itself. It reinforces itself by actually focusing you on certain things that inform you that that is more probable to happen. So there's a loop there. Reframing, and the idea of reframing, which we'll talk about a little bit, is important as well. But the part of this quote that I wanted to point out is that there's another dimension involved in frames, and it has to do with locality versus global, right? And what I mean by that is that frames often have to explain why what I see locally is related to what other people see globally, yes? So it's the way that we start having kind of an ability to speak with each other. What I see and what you see are somehow common. The frame allows us to start having those conversations. So there's this other kind of tension. There's a time tension, and then there's a global local tension as well. One last comment about frames before I go on to DevOps. There is a relationship here between intending and attending. So what we intend to do, all that futuring stuff I talked about, means that we're going to pay attention to certain things. and that's what we attend to. And the result of the attending is it shifts what we, the result of the attending shifts what we intend in the future. So there's a feedback loop here that says that actually designing things or creating frames changes what we will design in the future and doesn't stop. It's a loop. It's a feedback loop, like we describe in many ways, but it's a cognitive one that changes the conversations that we're allowed to have in our corporations. So, DevOps as a frame. The point of this talk is roughly to say that both DevOps and serverless can be thought of as these frames as opposed to as something you do. So they can be a way of thinking about the world and how you're moving through the world as opposed to something that you're doing, yes? And so I think if you look at it that way, you get some interesting results that don't normally get discussed in DevOps world or in serverless world that I think are important for us to start talking about. So the first one is this. Has anybody seen this before? Does anybody know what this is? Not a design school. Oh, we got one guy back there. Jeff Patton, he uses this. If you've taken Scrum training, sometimes you see this. The point that he's trying to make here is this idea that when you're trying to design something or make something in a team, you can kind of come to agreement. We're all agreed, but the actual shapes in each person's head is subtly different. So they're not actually in agreement because they haven't actually drawn those pictures on the wall. So they think they're in alignment, but they're not. The moral of this story, of course, is that what you should do is get everybody on the same page. Yeah? Everybody should have the same shape in their head, and that's how you know that everyone's aligned and going in the right direction, right? So this is an idea that in organizations, I'm sure you've heard it more than once, everybody should be on the same page. We should all have the same idea of what's happening. And I think at the team level, this is probably a useful thing to do. However, I think one of the things that DevOps does as a frame is starts pointing out that that's not necessarily true. I think one of the most interesting things about DevOps is just its name. So you've got Agile, right? Agile has like no teams in its name at all. It's just like a descriptor. But DevOps is literally named after two different teams. Yeah? And so it's immediately talking about a heterogeneity inside the organization. There are developers and there's operators in DevOps because that's what the name of the movement is, yes? And so the result of that is that we get this idea of multiple mental models. This is a diagram by Dr. Cook. And what he says is at the bottom here are all the things that you guys manage in the world, your code, your servers, and stuff like that. And then above the line, where it says representations, is all the mental models, the frames that we were just talking about. And what he says is that when you look at large organizations, or I probably almost any, I doubt there's anybody in the room who understands every single line of code that's running on their server. So somewhere there's somebody with a different model. But what Cook says is that there's multiple models, mental models inside of an organization. And that is advantageous. It's not bad, it's good that there are multiple models. And the reason it's good is because each of these, because of the bounded rationality of each of these actors, no one person can hold the whole system in their head. So the frames that they make in their mind of what exists below the line are what enable them to actually understand and make decisions about what's happening below the line. If they tried to put the whole thing in their head, they'd spend all their time loading the information in their head, and they'd never make any decisions. So the result of this idea of multiple mind frames or mindsets, or however you want to describe it, is that we shift the conversation from trying to create unified frames to creating relationships between frames. So this is where the important things happened in organizations where there's a massive amount of complexity in the systems below it. And so there is in DevOps always this idea of a boundary, and that there is a relationship that's happening across that boundary that allows us to do all the nice things that we were describing earlier, observing, inferring, anticipating, planning, all these things on the side are what the mental models enable us to do. So I think that DevOps, in a way, is a question about what kind of relationships are happening between these people with these different mental models. And I like to use a guy named Biffo, who's a philosopher, just to talk about this. And he has two different ways of talking about this. The first one, I actually did this one first. The first one he does is he calls it connection. And what he says is that when you are having a relationship that is based on connection, it is based on the idea that you can share strings of information and that you can interact as if you are syntactic machines that can interpret the same information in the same way. The really easy way to say this is, for Biffo, connection is about basically passing information back and forth between two computational units, yes? And so the model of this is that the teams are just computers and there's an interface that's passing information back and forth, right? And I think that in organizations that had kind of pre-DevOps ways of thinking about the world, what you had was a dev team and an ops team and a bunch of policies and forms that you had to fill out in order to move stuff from development to operations, which looks a lot like we think that we can reduce the relationship to data and the appropriate passing of data back and forth between these two teams. The second one that Biffo describes is conjunction. And he says conjunction is about the exchange and transmission of material substance, semiotic matter, common rhythms, interpretations of bodily movements and semantic nuances, nonverbal disambiguation of verbal signs. All of these things are what he calls conjunction. And I like to think that what he's talking about here when we think about DevOps is there's a certain set of work that we have to do together because some of the confusion and uncertainty can only be interpreted face to face. We have to work directly with each other and interpret through the problem signs and symbols that are not verbal or data. Yeah? So he likes to say that if you want to understand this idea of conjunctive communication, the second one, you think about two people who are courting, two people who are dating. Think about the fact that you don't yes, you exchange your basic this is what I do and stuff like that, but really you're trying to interpret another person's body language and what they're thinking, and you're taking risks and you're exploring an uncertain domain with someone else. That's kind of what he says. And he says that connective communication implies perfectly unambiguous interaction between agents. So I think that is difficult to achieve, but I do think it is a way of describing a lot of what was happening prior to kind of the way in which DevOps tries to talk about culture and inter-team interactions. And the result of this for Biffo is he says that as work is transformed into information, virtualization jeopardizes the affective relationships between people involved in the labor process. So what he's saying here is that it lowers the ability of when teams try to do completely connected interactions, data passing, it lowers their ability to deal with uncertainty, ambiguity, and any sort of interaction that requires kind of closer interactions with each other. So I think you get, again, this idea of connected DevOps as being the first one, which is the passing back and forth between two different teams. You get the second version of DevOps, which was maybe a little bit too much towards we should all be one team, hug ops, everybody should work together. There should be no difference between the teams, we should all work the same. This doesn't, for instance, gel well with Cook's model, right? This basically says everybody get on the same page. And that what we end up with in this kind of conjuncted model is a balance between the two. What we're trying to achieve is an idea that there is a set of shared practices that conjunct the two teams together. It's not all the practices. There are dev-specific practices, there are ops-specific practices, but there are shared practices, and those practices need to be done in a different way. And this set of practices defines what the boundary between dev and ops is. And I think understanding what those shared practices are critical. I also, well, I'll get to that, so I won't skip there. So I think DevOps is then not a preference for connection over conjunction, but it is a conversation, a negotiation about what parts of the organization, what parts of our work can we use data to talk about, and what parts do we have to work together in a more significant interpersonal way. This leads us to understanding a couple things, I think, or a couple conversations that I would expect to see in an organization that is doing DevOps. The first one is just what I call Pareto Knowledge, and that is, do you understand the most significant 20% of the adjacent work? So do you understand the 20% of what operators need to understand in order to operate the system, but also the most important 20%? Do you, on the opposite end, do you understand the 20% of what developers do that are the most critical practices? And how do we interact in order to increase the overlap of that 20% so that developers and operators can have a common set, a common frame, a common set of that global, local interests to create a shared frame? We also get, I would expect in an organization that's doing DevOps well, a lot of conversation about orthogonal concerns. So orthogonal concerns are all of your cross-cutting concerns in your organization. DevOps conversations, the frame should point you towards having a lot of conversations about things that happen across the organization and are not application-specific concerns. So I think the easiest way of kind of seeing this play out is things like DevSecOps, right? Is because sec and ops are cross-cutting concerns. That's one of the things that happens. You have to have security policies that go across all of your applications, not just in one application. So having conversations about orthogonal concerns, understanding what those are, and really focusing on ilities, I think is something that you get. The last one that I think that the DevOps frame should focus your conversations around or help you talk more about is boundary spanning. And the conversation I think that your team should be having about boundary spanning is whether the boundaries should be defined by policies or by roles. And the policy one is easy to understand, right? Like, is your relationship to other teams, the boundary between your team and other teams, literally written down in a policy? Do you have a change management board to figure out how you're going to change your interactions with other teams? The other one is a role, and I think the easiest way to understand what I mean by this is to look at what SRE is doing. Because I believe that SRE is what is called, in socio-technical systems theory, is called a boundary spanning role. And the idea of a boundary spanning role is that the boundary is created not by a set of policies or information exchange, but by a person sitting between the teams and negotiating between them in order to increase that shared practice area and the effectiveness of that shared practice area. So from my understanding or from my belief about SREs, things like SLOs and the implementation of SLOs are a way of starting to have a discussion about how information and practices need to be shared across teams that are implemented. The framing is implemented by a person, yes, not a policy. And I also think critically, if you are doing SRE, to understand that if they're doing boundary spanning, they're not doing the work for the other teams. They're not a DevOps team, yeah? They're a person who is helping other people understand how to work together better around specific practices. They're an architectural role as opposed to an implementational role. And they're supposed to be helping and guiding people down the path of understanding from one perspective how to increase the design for operation of a system. That's my theories on DevOps framing. Serverless. I think serverless is very interesting. How many of you kind of feel like there's like a little bit of tiff between DevOps and serverless? A couple people, all right. So there's an idea that like maybe serverless is kind of like no ops. It's like there's suddenly literally not a bunch of operators in my building. That's why I want serverless. So sometimes it can be in conflict. What I want to talk about is more like how we can think of serverless again as a frame, and what kind of conversations might we have if we think of serverless as a frame. So the most fun part about serverless is that it makes my whole little ontological spiel up front really obvious, right? Because serverless is an ontological undesigned proposition. What serverless is literally doing is saying, how about this? We can't use the word server in any of our conversations. It removes server from the conversations that we can have at work, right? I'm being a little cheeky, but I do believe that this is an important thing to think about. How many of you guys like talk about how many instances you have or things like this, where you're still renting a box from somebody, yes? So serverless is trying to tip the conversation in a way that we end up in what is called utility compute, where compute isn't considered owning or renting a thing, it's considered owning or renting processing. And if you want to talk about processing in your organization, you want people to understand the economics of processing something, you have to make them stop talking about boxes. Because boxes, servers, they understand how to use those, and they understand how to think about those in a previous frame, the way they used to think about things. Serverless is simply suggesting, if you actually change the conversation and don't let people say box, instance, server, they will have to describe what they're doing in different language. And that language will look more like utility compute. And that is one of the most interesting parts about serverless to me. So, what if you're adopting serverless? If you like, there's all sorts of arguments I could go down, like, functions as a service, backend as a service, all sorts of weird sub-arguments. But in the same way I didn't do that with DevOps, I don't want to do that with serverless. I want to talk about like what kind of conversations you should be having, or that I think the frame would engender inside your organization. So the first one, I think, is to understand that serverless is about cognitive engineering. And cognitive engineering is roughly saying, like, how can we engineer the system to fit in someone's cognitive system so that they can actually understand it, yeah? And it's based on this idea that most of our monolithic systems, one of the reasons they're brittle and old and we have a hard time changing them, et cetera, is because nobody can fit the whole thing in their head. And they kind of have to because of the way it was architected. So it's difficult for them to load the whole system into their head and understand it. So one of the things that serverless is trying to do is say, okay, yeah, everybody gets the idea of the right size team, right? Like 2-pizza team, we get that. We understand why that works. We can all read Brooks's Mythical Man Month. We understand network effects, all that kind of stuff. So there's an easy answer to what's the right size team, right? But the harder question, and I think one of the ones that serverless is trying to start to get people to answer, is what's the right size work for the right size team? Like, how do we know how big a thing a 2-pizza team can think about? How do we know what size that is? So I would imagine in an organization that's doing serverless well, in an attempt to take advantage of what they're doing, one of the things they're talking about is how big can the component be that the team can continue to stay in kind of cognitive control of it. They can load it into their head easily. And then the second thing that ends up happening there, because what componentization does is it says, I don't own the whole system, I've componentized it, I'm relying on other components, is, did we divide this system up in the right way? Have we sliced the system correctly into the right components? Because of dependencies and network effects and things like this, that becomes a major conversation. So Componentization, this is a very long text slide. I won't read the whole thing to you. But it is from Herbert Simon, and he calls it the story of Hora. And what it basically says is this. He compares two watchmakers. And he says there's one watchmaker. They both make watches that are equally complex. Same number of parts, same complexity, same difficulty of construction, all that kind of stuff. But one of the people has figured out that if he creates sub-assemblies, when someone calls him on the phone, and he puts the sub-assembly down, he only has to figure out how to continue with the sub-assembly, not with the creation of the whole watch. The other guy hasn't figured this out at all, and so every time someone calls and interrupts him, he has to put the watch down, and there's some chance the whole watch falls apart, and he has to rebuild the entire watch. So one system has sub-assemblies and one system doesn't. The sub-assemblies are components, and his argument is that this significantly increases the rate of change that the people with the sub-assemblies can have. So he actually can do things faster, but also he can combine those sub-assemblies in unique and innovative ways. So componentization rapidly increases the amount of change in an organization, but it also allows people to pick up the work, to load the work back into their head easily. So componentization should be a major part of the conversation you're having as well. The other kind of interesting part about serverless is that serverless moves utility to the component level, right? What do I mean by this? I mean that serverless considers what's running to be the component. Cloud considers what's running to be an instance that you put code on and then you start that code up, yes? Serverless doesn't think about the fact that there's an infrastructure there. It just thinks about the components themselves. So what it's trying to do is move all of the economics that we think about from cloud up a level to the component so that there's economics around the component level, not just the infrastructural level. So like stepping back and saying again, it's a conversation that's trying to change from let's talk about how much it costs to rent an instance or a box to let's talk about how much it costs to run this component, yes? So that utility function that's happening, the movement, should probably engender another specific conversation, which Simon Wardley calls FinDev. But the idea of this is that serverless creates a liquid market of functions. Again, I won't go to data. I could, but I won't. But the idea here is that the different components can each be now thought of as having economic value or costs. So instead of thinking about how much does it cost to rent a box and run a bunch of components on it, now we can ask how much does it cost to run that particular component? How much does it cost every time I instantiate it and ask it a question? The result of this is that it shifts the economic pressures that did not previously exist in software engineering teams onto software engineering teams. What do I mean by this? It used to mean that if you wanted to develop something, you had to convince some manager somewhere to give you a box to run it on, and that's the budget you had to justify. How often did you have to justify that budget? Well, it used to be you had to justify it as long as the server lasted. Nowadays, you have to maybe do it monthly because you get a bill from Amazon, right? This asks a completely different question. It says, how much does it cost to run your function? And because of that, it moves the economic pressures up to how do we crush all the waste out of this function so that it does the least amount of compute as possible to lower the cost of running that compute. The other thing that I think is important to talk about when you talk about FinDev is that it ends up being that serverless ends up not necessarily being a pure efficiency play. It's not just about crushing out the cycle time, the cycles that are used. It's also because it creates a market of components. So, it used to be when you built a system, you owned the whole system. You maybe bought code from other people, but you owned and ran it. Now you're going to have systems where the component that you wrote inside will have competition from somebody who's willing to rent it to you outside, and you'll have to compare the cost of, for instance, authentication. I have an authentication system inside. We have gone to the serverless metaphor, so we're now calculating the cost of each instantiation and request to that authentication service. We have determined that it costs us 15 cents to authenticate. On the other hand, we've figured out Azure will cost us 5 cents to authenticate. Maybe we should move to Azure because it will be cheaper per instance, yes? So it creates a marketplace that allows the components to be swapped in and out. As a result of this kind of economic pressures, there's a couple other weird things that I think happen. And the first is that let's say there's a list of everything that has to get done, and then there's two teams. There's a team that is responsible for, I don't know, one function, team that's responsible for another function. When we apply economic pressure to it, you can imagine the economic pressure is kind of like squeezing all the waste out, right? And here is the problem that you might see, is that it's not just waste that gets kind of squeezed out from economics. One of the things that's very predictable when you use economic pressure on a system is externalities are formed. And externalities are simply the work that, some set of the work that used to get done doesn't get done anymore because neither team takes responsibility for it. And now it's just there. So basically, I have economic pressure on my team to crush the thing. So I start offloading stuff to other things. And all of a sudden, there are teams being formed to deal with these externalities. So you're not actually getting the economic effect you want. You're just moving it around to other teams. Does that make sense? So paying attention to externalities and making sure you understand that the economics of serverless will cause externalities is another kind of important part of the conversation. And Herbert says it this way. The way to solve this is division of labor among subsystems creates externalities that are caused by the interdependencies that are ignored. What you want to do is create a system that permits the maximum decentralization of final decisions to the subsystems, maximize the use of relative simple and cheap coordinating devices like markets, so that the decisions stay in the subsystem in order to avoid this. Another really quick one about serverless. Complexity doesn't go away just because you squeeze it out. It usually just goes somewhere else. And this is one of the reasons why I think DevOps and serverless will end up being bestest of buddies. Serverless is network full, and network is distinctly an operations problem. All the network effects, the questions about how you interact between components are critical to understand and are distinctly operational concerns. And I think that the best teams in the world will start having operators working with their serverless teams to understand those networks. Final point, and then I will release you to beers. You should be talking about the modularity of a system in this particular way, the degree to which a system's components can be separated and recombined. Because of the economic effects and the network effects that I was describing with serverless, the cost of change, which Grady Bush likes to say is the only decision that you should make for architecture, the cost of change should be a major part of the conversations in your organizations. How much does it cost to change this component? Not just run it, but change it. Because the cost of change will define whether or not you can move from one less economically viable component to another. So focusing on making sure that you can swap out components should be a major part of your serverless thinking. So finally, these ideas, DevOps and serverless, if I've done my job well, I've convinced you that they're things to think with. They're frames to think about what you're doing, to ask questions about how you can do those things better, and that they're not things that you necessarily do. They're not answers. They're proposals for thinking about something. A final idea is that DevOps and serverless well map to this idea of what's called cosmopolitan localism. DevOps itself is about cosmopolitanism. It's how your teams fit into a larger cosmos, into the larger system. How does my team fit into the bigger system? Localism is well defined by serverless. How do I minimize what I'm thinking about so I can focus on my local concerns? Cosmopolitan localism is the idea that the only way to successfully create sustainable systems is to combine these two ways of thinking together and make sure that you're balancing them. It's creating a network of interconnected communities and places at the same time that are open and localized. 2 books you might like on frames. Thank you for listening to me rant.